All right, so this is a comparison mat, and that's why it has the question mark in the middle. As we work with this today, we're going to be answering the question mark for how does one side compare with the other side. So right now, the only things I have are on my left side, but we're going to be comparing different expressions, left versus right, as we go. So anybody interested in reading this morning? Yep. Marvin, thank you very much. We're going to start with in chapter 4.
In chapter 4, we work with writing to simplify expressions. As we will expressions, we learn and sculpture by simplifying them. By defining right terms, we will make it zero. In this lesson, we will do we use the tool for the expression. We will allow you to determine whether one person is greater than the other or the other.
So we're looking for, are these things equal? And we've talked a little bit, in this class we've done more than the afternoon class, about the algebraic method for solving equations, like solving for an unknown. So now we're going to start to use physical, tangible, like we can move and manipulate. We've worked with the algebra tiles, right? This is not our first time with them. Okay, so we're going to start to get a bit more detail every time we get them back out. So now we have this comparison map where we're going to be comparing one expression with another expression. So remember that to represent expressions with algebra tiles, we need to be very careful about positives and negatives. With our physical tiles, how do we know positive versus negative? The ones that you're looking at in front of you, the colored tiles. What did you say, Aubrey? Somebody said it. Francesca?
It says that the grayish ones are...
Ooh, nope, what we're looking at. The ones that we have on our desk. Like what you physically have in front of you. What means negative? Red. So, this is slightly confusing. The empty tiles on the images that they show us are the negatives. We are going to use our red side for negative. Make sense? The other colored sides are different colors because they're different values. Now, the fact that x and x squared are the same color still doesn't mean that we can combine them. It means they share a value. They share that side one. It would be easier if I could actually scroll here. So, we are going to set up 6-1. So, Ignacio and Oliver had two different expressions. They have the expression on the left side, the expression on the right side. Take a moment, build that on your mat. Now, the gray that they show us, that's going to be like purple. Can anyone make an observation for me, what we notice from both sides, or just anything that you notice? Give me one thing that you notice. Ellen, what's one thing that you notice? Just any, I mean, what could you make some kind of statement about, like, both sides have, or only one side has, or both sides are using positives and negatives. Love it. Emily, anything that you know that we could do when we have positives and negatives? Ooh, what does that do? What happened? It does something. Delaney? So if I put this positive with that negative, what happens? Turns into 0 because they cancel. So do that, simplify this as much as possible, and then figure out which side is worth more. Who has more value? Take a moment with your partner. Verify that you two both get the same answer. Then try to determine, now don't write on this piece of paper, because we're going to keep using it, but then try to determine, is it equal? Is 1 greater than? Is 1, well, if 1's greater than, then 1's going to be less than, but like what symbol would correctly compare these two? So take a moment. What do we call it when we have a positive and a negative together that cancel out to nothing? Patrick? Yeah, additive inverses. We have another name, though. I don't know how much we've covered that here. We are going to start to use, and I have a couple hints on who we will, but these, we call these zero pairs. When things pair up, when they are opposites, when they are additive inverses, they make zero pairs. So it kind of sounds funny. You're like, oh, we have 0 pairs of something. No, it's not. This is a pair that makes 0. Okay. So now, Penelope, you were just trying to say, what about something, some symbol name? Greater than? Why are you saying greater than? Okay. How do we say it then? Because. Well, what did this side turn into? Positive. What's the value of the left side? Stop whispering stuff at her. On the left side, this canceled to 0, this canceled to 0, and this canceled. Ah, so we have 2, and what's the value on the right side?
Oh.
You okay, Alan?
Yeah, my.
Ooh, yeah, Delaney finally got it. -3. Yeah, you had to do the whole backwards thing. Are there questions on how we got to 2 on the left side after we canceled out the zeros and -3 on the right side? Sorry, we should also that cancel out also. Any questions about this? Okay, look at problem 2. Oh, it's up there, not written. Now, your other handout that you have, this one, mine got a little moist because I had a water malfunction this morning. It did. It's sweating. Makes paper not very good. You may draw on this paper. And that's trash now, obviously. So, if you see a 0 pair, circle it, but then how do we show that the 0 pair really kind of like goes away or like doesn't matter? We could circle our 0 pair. So everybody with me on that paper, circled your positive x and your negative x, the gray one and the empty one. And now we're going to say they no longer matter. So we just draw a little arrow with it leaving the map. Now another thing that we can do is look for what's the same between both sides. Because if we have the same values between both sides, then if let's say I'm comparing like Liam and Patrick, and we got Liam's side over here, Patrick's side over here, they both have a lot of stuff in common. So if we're trying to figure out who has more or who has what value, if they both have an x squared, do I really need to care about that Patrick has 1 and Liam has 1 and they both have the same amount? Does it make a difference? So what I'm trying to get across, and I don't think I'm doing a very good job of it, this x squared and this x squared, both positive x squareds, right? Because they're gray on our paper, both positive x squareds. If I got rid of that and got rid of that, would it change the comparison between Liam and Patrick? What if I got rid of these made a 0, you guys said, so we get rid of those. These make a 0, so we got rid of those. What is still shared or common between the left side and the right side? 4 of the negative 1 tiles. So if we say, well, okay, Patrick has 4, so if we take those away, then I would also have to take 4 away from Liam, who still has anything left. Liam still has something left, so that side is bigger than this side. Now, go ahead and sketch that stuff on your paper. I'll give you a second. Draw the circles around 0 pairs, or the fact that these are the same. You might write a little note that these are the same between both sides. Sorry, that's the same. I'm with this one. So here's the 2 different things that we did. If I have opposite quantities on the same side, right, these additive inverses, they cancel each other. But if I have the same values on the 2 different sides, they can both delete also, because that's like taking away from both people. If I go on and I take an x squared from Liam, it's not fair unless I also take an x squared from Patrick. So really what we end up with here, Liam has a -1. What does Patrick have? Everything that we canceled out and got rid of. We got rid of everything from Patrick. Careful here. Which is greater? Patrick?
I got more because his is negative.
Patrick has more because he has nothing.
But he has less than us. But he is negative less.
0 is greater than -1. What this really is telling you is -1 is lower than 0. It is lower than. So we could also write this out with the algebra, but that'd be really weird. Don't write this. Just watch with me for a minute. If I try to write out what Liam has on the left side there. Liam has x squared. Then he also has an x, but then he also has a -x. Right? So if I said, even if I wanted to make this like plus a negative, then he has 4 negatives. Or, sorry, 5 if I'm talking about Liam. This is kind of redundant. I'm going to add an x and then I'm going to take one away, or I'm going to add a -1. That's why when we go through the simplification process, if you see opposites, just tell yourself, oh, those don't matter, and we wouldn't need to worry about that at all. It really has x squared and 5 negatives. Patrick really has x squared and 4 negatives, because these delete each other. They're additive inverses. Questions? Try 6-3 on your own. Get rid of anything that you can, anything that can cancel out. You can build it with tiles on your mat if you want, or you can just do it on here and draw. Notice how below it says expressions. Once you cancel out what you're able to cancel out, we'd like to write an expression for this. Who figured out that we can cancel out a 1 and a -1 over here? on the left now, I'll put the little comparison question mark. What would be the expression on the left now? Kate? Kate here today? No, she's not. Francesca, do you know what we would write for the left side now? But we don't need to worry about the zeros. So start with variables. What do we have on the left side for variables? So we're looking so if this splits, we're looking at the left side, only the left side. So this is my variable tile, right? How many of those do we have? Just one. So we have 1, and that's a positive x. How many constant or number tiles do we have?
6.
Yeah, 1, 2, 3, 4, 5, 6. So we've got an x plus 6. Please write that down on your paper down below where it says expressions. You can leave in between them blank or put a question mark for right now because we don't know how it compares. The right side. What can I do on the right side? And then I want to write this out. Nathan, what can I do on the right to make things easier?
Is it okay?
Okay, how many? Or how do I do it?
You put the gray one with the right one.
Yeah, the 2 negatives with 2 of my positives. Those aren't needed. So now what do I have left on that side?
2.
And yeah, we have the x and we have 2. Now, since I have x on both sides, I don't really care about it because they both have the same thing. Which side has more right now? Why? How do you know that, Noah?
Because they're both positives, and the left side has more positives.
So Alan just told me since they both have x, and x plus 6 is going to be more than an x plus 2, which makes sense. And if you need a reminder on your paper, this is our greater than symbol. So please write that down where it says expression below 6.3, right here on your paper, below 6.3, and then put the greater than symbol so you know x plus 6 was greater than x plus 2. Any questions? Yeah. No, you don't have to write the 1. You have to have the x. So the 1 is unnecessary. It's kind of redundant. So notice there I did put the 1, and there I didn't. Both correct ways to do it. Other questions? Thank you very much for listening. Check out 6.4. It is not on that paper. Because we want to reiterate those 2 ways for you, and whatever you want to write down to show this, I'm going to give you a moment to write this down. So notice the 2 ways, and we just talked about this, but I want you to see this again right here. If I want to make less to look at, less to think about, less to deal with, get rid of as much as possible. So they notice that since we have a balance, right, what we're looking for here is keeping things balanced how they are, right? So I can't actually break any of those math rules. So if I take an x off of this side, I also have to take one off of that side to keep things fair. Does that make sense? And this is what we were just looking at, that we could just not look like we could get rid of those x's and not worry about it. Then we can also, once that's done, get rid of any 0 pairs. Now they show it on the right side. Can I do it on the left side? Yeah, I can also do it over here. And that makes my expressions turn into an even easier. What do I have on my left compared to my right now? 6 versus 2. And it's the same thing we just had. You. It's the same thing we just had, but without worrying about the x's. So less to write, less to do, making your life easier. Are you with me? We want to get rid of everything we can. We want to look at as little as possible. So let's check out 5. I'm going to give you a couple minutes to work with your team. Try to figure out everything we can do to get this down to the most simple form possible. And there are 2 different ones here, A and B. So you want to get rid of all 0 pairs. You want to get rid of all balanced sets. If you have the same on the left and the right, have at it. There's a bunch. Then E and F kind of flip gears. So E and F will do those together, but try, if you get done with A, stick up a hand to check your answers. Go ahead and build A on your map. I feel like it's super quiet and you guys are like, maybe if I just hide over here. Build A on your map. Like physically build it. Maybe this one. Well, we have 5 positives. 3 negatives. Check your partner, make sure that they're good and they're building the right thing. You should end up with something looking similar to this. Still see people working. Really. Just gonna use cards for who can help me. Renard, what's the first thing that you think about us being able to do to make this easier? Pair, what kind of pairs? You want to use the 1s or the X's or what? 1s? So over here on the left side, how many 0 pairs can I make with my 1s? Do you know? Otherwise I can just, yeah, 3. Because every positive negative pair that I have, so I'm just going to stick these up in the top corner. So make those 0 pairs. And since they're 0, they really don't matter. You could actually move them off of your chart if you want, or you can keep them here so that you can still see everything we had from the get-go. Do that on the right side on your own. Make your 0 pairs with your 1s. So I believe my left side and my right side have each canceled out 3 sets of positive and negative 1s. You still with me? Now, what could I do, Mr. Hopkins, to continue to make my life easier?
Cancel out the X's.
Cancel out, how's that? Because there's 2 different ways that we can do that, actually.
Well, there's 2. There's on the left side. There's 2. There's 2 positive X's, so you can cancel. Wait. Actually, there's a positive and a negative.
So
you can
first, 0 pair. 0 pair whenever possible. Make your 0 pair. Then I have the same X's on the left and the right. I have 1, 1, 1, 1, and an extra guy. Because this, give me your eyes up here for a minute. This is where we can make our life ridiculously easier. These are all zeros, they don't matter. These are all zeros, they don't matter. The only stuff that matters is here, when we're trying to compare left with right. I think right now you could probably tell me which side has more. The right. Because we see there are more tiles and everything we're dealing with is positive. I can get there really easily if I say, well, these are the same, remove them. If I take the same thing off of each of them, it's still fair. If I take $5 from Patrick, I gotta take $5 from Liam. Then, these are the same, remove them. These are the same, remove them. How much more does the right side have compared to the left side? It's got 1 extra. So, from the beginning, if we write this whole thing out, we have a lot of tiles to deal with, right? All of this stuff going on. But at the end, once we group all the 0 pairs, and once we cancel everything else out, we just really have that the right side is 1 bigger. Now, if we were to write this out, so below your thing here it says expressions. Okay, so if we were to write this out from the beginning, my left side, sorry, see if I can focus back. Maybe it's not going to focus. We'll just do this. So below this, please, our left side had to start. So now with me writing, please. We had 2 x's of the positive and 1 x that was negative. We had 5 tiles that were positive and 3 tiles that were negative. We found out the right side was bigger, and the right side initially had started with x plus 6 plus a negative 3. If we had wrote it all out from the beginning, right? I have eyeballs at me. What are you? You look upset. Okay, making sure. Because I'm going to goof up. I expect somebody to catch it, and that's why. Notice we could do the math, right? We know how to add and subtract positive and negatives. This combines to just give you x. These combine, you don't have to write this part, to give me just 2. These combine to give me just 3, and I still have x. We get to x plus 2 compared to x plus 3, and then that's really easy to work with. Questions on doing that process? Either way of canceling out either 0 pairs or balanced pairs. Do B. Try B on your own. You do not have to physically do it. I just need you showing what you're doing on both sides. You don't have to make the tiles and everything on your paper. Can I cancel out these 0 pairs? Yeah, there are 0 pairs to be made. Can I cancel out anything that is balanced on both sides? Yeah. Alright, I think I got all my 0 pairs. Once you remove your 0 pairs, your expression should be a whole lot easier to write. So if I don't care about any of the things that I've now turned into zeros, we're kind of going to skip the first step here. So if I don't care about those and don't write them, what do I have on the left side right now? Can you help me, or am I using cards? Grant?
Question is, what do you have on the left side?
Yeah, now that I got rid of those zero pairs. Okay. 1, 2, 3, 4, 5. Yeah, I have 6 constants. Is there anything else? You're ahead of me, aren't you? Yeah. So we have 6 constants. I don't know where that. 1, 2, 3, 4, 5, 6 still up there, and 2 negative x's. Negative 2x and 6. Or you could say negative 2x in parentheses. Or you could say 6 plus negative 2x. There's a bunch of ways we could say this. Compared to, so for now I'm going to put a little verses here. What's my right side now? 1 and negative 2x. So I've got a negative 2x over here and a positive 1. Hopefully some of you have caught on with what we're going to try to do. Is there still an easier way I could deal with this? Patrick?
Take off the negative 2x.
If I have negative 2x over here and I get rid of that from this side, then I can also get rid of the negative 2x from this side, because that's what we call balanced pairs. Same thing on both sides. We can get rid of it and not think about it. So now I have 6 versus 1. My left side versus my right side. And that should be easy to deal with. Which side's bigger? A?
Well, this is Matt A.
Yeah, the left side, the Mat A, right? I hate that they do that because we're on part B, and now we're going to have Mat A, Mat B. Like, I just don't like that. Left side versus right side. Questions here. We really get to the point that 6 is bigger than 1. Now, could I still remove something from both sides? What would I remove? Emma? I could take 1 off of each side. So if I take that guy away and this guy away, I end up with 5 is bigger than 0, which we know. But those skills are how we're going to end up solving for the variable value. Right now, today's lesson, today's homework is just comparing, isolating, combining like terms, putting together what we can, canceling out what we can't. Try Mat C. We should be getting better at this. Make 0 pairs, then cancel out balanced pairs. Yeah, so then you still haven't really said, which is you haven't given the inequality symbol. You're right. Like what you've done on that, I didn't check that one. We've got here. So we'll do that together. We'll put it down there. Matt, are there 0 pairs that I can cancel out?
Yeah.
On the left side, what 0 pairs can I cancel? Is it with the variables or with the ones? The ones. So these can cancel and leave, and these can cancel and leave. Positive 1, negative 1. Did it twice. On the right side, are there 0 pairs?
Yeah.
Yeah, there's 1. So this positive 1 and negative 1, that's gone. So we don't have to worry about any of those. Anybody find any balanced pairs? Allie, what do you think? Are there any balanced pairs, things I can get rid of from each side? X. So if I get rid of this X, I gotta also get rid of this X. Am I done? Ah, there's another set of X's. So this X, get rid of that, and this X, get rid of that. What do we end up with, Patrick? 3 and 3. Ooh, what's that tell me about my expressions? Monica? They are equal. So those two expressions would end up equal. We're going to skip over D just so we're running out of time. In E, actually, Grant, can I have your paper? You're ahead of us. Like, it's fine. It's good. Grant was moving on pretty quickly, so I'm going to steal his paper first. So look at what Grant has done for E. E tells us you have 3 X's and -4 and -2. So he drew 3 X's and 1, 2, 3, 4, 5, 6 of the ones. Doesn't have to be perfect. Draw something like that on your paper real quick. 3 X rectangles. These are not the squares, these are the rectangles. And then 6 empty boxes showing the -6. The right side tells him he has 3 sets of X and a -1. So if I was actually drawing this, in my mind, I'm thinking, okay, in X and a -1. Okay, that's shaded. In X and a -1. That's shaded. And in X and a -1. 3 sets of X and -1. However, Grant went ahead and thought about, well, that really means that I have 3 X's. And that really means that I have 3 -1s. So he just drew the 3 X's together and the 3 -1s down at the bottom. Either way is totally fine. He then did what type of cancel? 0 pairs or balanced pairs? Were these 0 pairs or balanced pairs? Balanced, right? They're on both sides. So he did the same thing on both sides, took away 3 X's, and he ended up with a final value of -6 on the left compared to -3 on the right. And he found out that -6 is less than -3. We know that because -6 is lower. Questions on this? So again, because some of us weren't here at the beginning of class, your homework should just be done on a clean, fresh sheet of paper, nice header, everything else. I will likely be collecting those to see how we're doing at the beginning of combining like terms and working with these expressions. So please get that done by Wednesday. I would not collect it tomorrow. That's mean. Single day turnaround. What's up, Ethan? You're looking like you wanted to say something. Everyone good? Any last questions? All right. Thank you very much, guys. Have a good day. Nah, I'm keeping it.